Sorry, 1 second. Hereby, I open the academic ceremony in which Manon J.C. will defend the academic thesis, Importance of Material Production and System Analysis in Design and for Plastic Circularity. Dear candidate, may I invite you to present a summary of your study and the conclusions of your thesis?
Dear Prorector, thank you. Dear member of the jury, colleagues, friends and family in the room and in the audience, good afternoon. During the next 15 minutes, I will introduce the main outcome of my PhD project that I did between Maastricht University and the Technical University of Denmark in the Horizon 2020 project for Circular Plastic Network for Training. In this project, I was early stage researcher number 3, and I work on design for plastic circularity. I think we can all agree that we need to move away from the linear economy where we extract the resource, we produce, we use, and we waste the product. It leads to a huge amount of waste, as well as depletion of resource, pollution, and environmental impact. In this context, the European Commission introduced in 2018 the Green Deal and the main principle of circular economy, in order to move from the linear economy to the circular economy, where waste do not exist anymore, and it's now a resource circulating back in the loop for as long as possible. If we apply this principle to plastics, it will give the plastic circularity that we aim for. However, plastic circularity in Europe is not yet implemented. If we draw the plastic flow of Europe in 2020, we can see that it has been produced 54 million tons of plastic, and it resulted in a 30 million tons of waste. Mainly, this waste will be sent to incineration, and only a small part will circulate back in the loop, around 5.5 million tons. And we need to consider that in the future, plastic production and consumption will increase. If we use material flow analysis to draw the production, we can estimate that between 2020 and 2050, for these 3 types of polymer in the sector represented on the figure, it will almost double. And of course, if production increases, as such the plastic waste production. And if we do not implement drastic measures, it will remain a linear incineration economy where mechanical recycling only plays a small part. That is why we need tools and analysis in order to support decision-making, to implement powerful intervention. That leads me to my research question that I investigated, that was, how can the driver and the barrier can comprehensively analyzed when assessing design for plastic circularity? To answer this question, I did 3 types of analysis. The first one at the system level, where I investigate the role of the plastic value chain to implement the plastic circularity. And I will present the systemic framework I created in order to evaluate the contribution of the initiative to implement the circular economy principles. At the second level, I zoom into the product level, where I try to quantify the substitution, meaning the replacement of primary resource by secondary material, by quantifying the losses occurring during the waste management system. I will present the main outcome of the comparison from the framework extracted by literature review. And in the last analysis, we finally zoom in the material that we use in the plastic to investigate the role of the chemical contamination that can impact the plastic circularity. I will present the result of the study case I did on solvent-based ink printed on flexible plastic packaging. So, if we zoom directly on the result of the first analysis, we chose initiative because they represent a claim to implement plastic circularity. In total, 54 initiatives have been selected from a literature review based on academic paper, industrial report, but also European Commission report. They have been categorized in 7 categories based on their main focus. So, for example, some of them focus more on collection, others on sorting. Each initiative has been evaluated according to 3 pillars and 17 criteria in total. The objective is to draw a bubble graph where the likelihood of complying with the circular economy principle will be represented on the x-axis. The likelihood of being implemented will be represented on the y-axis. And finally, the third pillar, that is the size of the bubble, will be represented by the size of the bubble. So if an initiative scores positively all the criteria, it should be on the top corner of the graph, and it should have the biggest size of the bubble. However, when we plotted the result, it was not the case. And we cannot use this analysis to say this initiative is bad or good, but we can use this analysis to describe the barrier and the levers to reach plastic circularity. So the analysis revealed that the lack of collection, the lack of awareness at the stakeholder and the consumer, but also the limited end market and the cost of the intervention will result in a suboptimal outcomes. However, the analysis also show that a shared common vision of plastic circularity as well as a strong governance with policies and regulation will support the transition. So this type of analysis tells us that not a single initiative will be enough to drive the plastic circularity objective. However, it is not enough to use qualitative analysis to quantify the circularity at the plastic product level. That's why we dive into the second analysis, where we try to quantify the substitution potential of a plastic waste based on its recyclability between collection and the use of the recycled material in a new product. To do that, we decided to use the primary equation introduced by Vadembo et al. In 2017, where it quantifies substitution based on several parameters. So the parameters were the quantity of waste, the waste management efficiency, and the suitability of using the recycled material in the product. However, this framework or this equation is not ready to use, and it needs improvement. So before to create a new framework, we decided to dive into the literature review and to investigate if some authors were already trying to improve the quantification of plastic substitution. It resulted in 8 articles that we will try to compare to the initial one based on this schema, and we will try to juxtaposing them. It gives a complicated figure, but I want to highlight few points here. That some of the authors, they focus more on the waste efficiency part, where they try to quantify the physical loss occurring in the waste management system. While other authors, they try to assess the suitability of using the recycled material by defining the quality loss. And it's the first time that quality loss is now usable as a quantified parameter. I will have a chance to explain a bit more this part in the last analysis. And then we have other authors that try to use framework here to describe the outcome of chemical and mechanical recycling without taking into consideration the full equation that I presented at the beginning. It leads to some uncertainty because if we extract some of the value from the framework themselves, for the flexible packaging, for example, that will end up in the blow film application, we can see that it gives different value. It's an issue because this type of value can be used in life cycle assessment, for example, when we try to calculate the environmental impact of recycling. And it will be necessary to do the environmental impact for the technology we have, but we also need to have a good framework, systemic and uniform to quantify the substitution for plastic products that are sold as recyclable, and that should contribute to plastic circularity. That leads me to my last slide, my last analysis, about mechanical recycling of flexible packaging. We choose these analyses because they have a low recycling rate and they have a low value, meaning that not everyone is interested to buying it to make a new product. Solvent-based ink, they are ink that are based on a solvent, a binder that traps the pigment and the additives on the surface of the packaging. When these inks dry, the solvent evaporates and it introduces a contamination between 1 and 3% of the total weight of the packaging. So we ask the question, what is the quality of the secondary material and does it impact the use in the plastic product? To do that, we included 5 types per sample. The one on the top is the one that is unprinted. The 2 next ones are printed only with a binder, either polyurethane or nitrocellulose. And the 2 last ones are printed with the ink, so a mix of a binder and pigment. All the samples have been shredded, compounded, and used to produce a 100% recycled blown film. It gives different results and different quality. And based on the characterization we did before, we tried to discuss where does the contamination come from. So for the polyurethane, we know that the polyurethane will remain and will create some volatile organic compound. For the nitrocellulose binder, in that case, it will degrade at the temperature of extrusion, and it will affect the aesthetic and the sensory. In the case of the inks, either if they're based on the polyurethane binder or the nitrocellulose binder, the presence of the pigment will affect the aesthetic and the sensory of the film. But does it affect the usability of this recycled material in a product? For that, we use the quality factor that have been introduced by Deme et al. In 2021 previously, where it's a function that tries to quantify the match between the properties of the recycled material and the functionality of the product. So if the quality factor gives you a 1, you can use it. If it's a 0, you cannot use it. We did that for 4 types of properties. The first 2 are the processability and the mechanical properties, and they are common for the 2 types of plastic products. We can see that in that case, the contamination do not affect the usability of the recycled material in the product. However, when we choose other types of quality factors, such as aesthetic, that include the A's, the difference of color and the number of inclusion, meaning black spot, we can see that the introduction of the inks will disturb the use in the flexible transparent packaging because the result is kind of dark black. In the last quality factor, we introduce a new factor about sensory, where we compare the ratio of volatile organic compound in the virgin material and the one that is printed. And we found very different results, where either the use of the binder and the ink disturb the usability of the product, the usability of the recycled material in the product. And if we define the limiting factor between these 4 functions, it gives us where we can use this recycled material in the plastic. We can see that we can conclude that the use of the inks or the binder will be challenging to produce bin bag and will not be possible to produce flexible transparent packaging. To summarize what I deliver in this project, at the system level, I produce a systemic framework able to evaluate the contribution of the initiative and identify the levers and the barrier. It has been published in the Journal of Resource Conservation and Recycling. At the product level, I justify the fact that we need to calculate substitution in a systematic way. It is feasible, but it has to be done case by case for each plastic product. It will result in a publication after this PhD. And at the material level, I quantify the impact of the chemical contamination for a specific example. That was the 2 solvent-based ink. And we describe the quality of the recycled material as a barrier for plastic circularity. And it has been published in the Journal of Hazardous Material. To conclude, on my last slide, these 3 types of analysis, they bring new insight to break more radically from the linear economy. They also bring new knowledge for decision-making, and they bring some knowledge also to create assumption in other types of tools, such as material flow analysis and life cycle assessment. However, it's not enough, because we will need to move from the theory to the practice when it comes to apply plastic circularity. And for that, we will need to do socio-economic assessment, because each intervention or initiative will have a cost. And as well, all the initiatives are not sustainable, so it will be necessary to do environmental impact assessment. Plastic is also a global issue, so in order to tackle this global issue, it will be needed to extend this work to other regions than Europe. And finally, I want to bring your attention on this point, that I focus on material circularity in this project, especially the waste management system and the recycling, but it will not be enough to mitigate the global plastic crisis. If recycling is part of the solution, it will be definitively needed to drastically cut plastic production and improve the measure for reducing, preventing, and reusing the plastic. Thank you for your attention, and now I give back the word to Prorector.
Thank you very much for your presentation. Before we proceed with the opposition, let me briefly introduce ourselves to the audience. So on the opposite side of the room, we have Professor Ragar and Professor Damkaart, who are the thesis supervisors. And then we have Dr. Vervoort. And on this side, on my far right, we have Professor Kemp and Dr. Harings, who's the secretary of this degree committee. And finally, my name is Thuisman. I'm the pro-rector, so I'm representing the rector for this meeting. And now we start the opposition by Professor Kemp. Professor Kemp is Professor of Innovation and Sustainable Development at our Maastricht Sustainability Institute and a Fellow of UNU Merit, post at Maastricht University, and he is the chair of the assessment committee. Professor Kemp, the floor is yours.
Thank you, Pro-Rector. Dear candidate, dear Manon, I want to start by saying that I found the thesis very interesting and relevant, because the topics of your thesis are interesting and relevant, and also because the writing is very clear, which is appreciated. I also appreciated the effort you made to synthesize the findings of you and others in what you call the introduction, with which I would call synthesis. I asked you to indicate in what field you operate, and the answer that I got is environmental science and material science. So there's nothing on circularity, I noticed. I'm not working in any of those fields because I'm a social scientist working on innovation and sustainability transitions, including the transition to a circular economy. Now, in the social science field, we don't look so much at molecules, but people and social relations, at systems, socio-technical systems, and also the interconnected barriers to system innovation or transitions, which is what I do, among other things, in a project called Lisiecki, I think you know that, which is a project about packaging plastic recycling. Now, your analysis talks about the limitations for plastics recycling from a technical point of view, which have to do with the availability of the waste material as a resource and also the quality of the secondary material, and ways to improve that. I think this is very valuable, and I think you did a good job at that, but others are better qualified for judging that. You also did a simulation analysis of plastics recycling using MVA. I have to, as I indicated, I struggled with the understanding of the calculations, but you offered some explanation for that. Now, my question is not about the future of plastics recycling or plastic circularity, but about the recent past. So my question is about the system dynamics that occurred in terms of moving to circular plastics. And I'll make it more specific. That's the first question. Can you tell me the increase in plastics packaging recycling and circularity in the last 10 years in Europe?
Dear highly esteemed opponent, thank you for your question. If we talk about the recycling rate, for example, for this type, I will say that it increased. I'm not sure exactly about the number, but the difference between the 10 years ago and now should be less than 5%. So I will say we start maybe with 10% and we now maybe at 14 or 19% recycling rate.
Yeah, that's not impressive, is it? In a time when everyone is talking about plastics should be reduced and should not end up in oceans. And was this change orchestrated in some way, or was it more a market-based development, governed by prices?
I will try to rephrase your question. You asked me if this difference is...
Yeah, so this increase of 5 percent points, was that orchestrated, or did it happen through the market mechanism, mostly?
I think there is few answers that I have in mind. For example, I will say that it's the use of the policies, because we had a huge push, like from the European Commission also to increase it, because we know it comes with a lot of drawbacks. So it was like how we can change the situation. It's also coming from the manufacturer. I think that's a calling from the consumer, and also the fact that if we go to resource depletion, they will need another feedback to produce plastic packaging, so they need to have this recycling. Yeah. So that will be my 3 type of answer, both.
Okay, yeah. Well, you didn't study that so much, so it's difficult to give a very detailed answer. The second question, is about my own literature, where people also are critical of the circular economy. They say, it's a buzzword. It hides from view that we're actually in a linear economy, and I think it also is dressed up, like the emperor, as being able to do wonderful things which are not happening. Now, in the social literature, some people consider the circular economy a ham-bake. Do you know that concept? Ham-bake.
I'm not sure.
No, well,
I
also learned it recently. Ham-bake stands for hegemonic, vague, and big. So that has been ham-bake.
Get it.
And it's called a ham-bake because it's based on a metaphor which is false, of the industrial symbiosis, mimicking nature, where, unlike nature, a circular economy is not stable, not a stable closed system with no waste. There is resource use and there is waste and pollution. And I think your analysis also shows that. Now, the business case for circular plastics is not very strong. I mean, there's businesses, but overall it's not very strong. And I'll read something out for you. Considering the supply limitations and price volatility, the inferior quality, contamination, legacy substances, and other inherent uncertainties in secondary resources, it's difficult to see why anyone at the firm level would be interested in using waste as a resource in a circular economy instead of the well-functioning value chain with primary resources. And then the conclusion of this article is we need a different conversation. More honest, modest, concrete, and more inclusive and transparent about the circular economy. Now, I would like to have your opinion about that. And not simply as, well, I agree or something like that, but, you know, what does your research lead you to say about this, and in your own words?
First, I think circular economy is a big umbrella. I didn't know the word you introduced, but for me it's just a vision that makes people move in the same direction. We need to have this common word where we can be attached to and then move in that direction. However, I really do not think it's enough, and that there is a lot of drawback with plastic. For sure, waste will be contaminated. There will be a lot of low value and limited market, and we'll need to push for research like mine, where we do not only investigate recycling rate indicator, but we're trying to find solution to try to pull the good string, or to pull the good umbrella. I don't know how to say it. I think I'm also in the pessimist side of the circular economy, where I don't think we do enough with recycling, and I really think we should push for the reduction, the prevention, and the reuse. That I did not investigate a lot in my PhD because it was not the main focus, as you say before. I have a leg in the material science at Maastricht University and one other leg at the environmental impact section in DTU. So it was hard for me to link it more than that. I had the chance to dive a bit in this reuse and prevention in the paper 1, for example, or paper 4, with a bit like how can we look at the regulation? Are they strong enough to implement this prevention? And my answer is no. And we're not doing enough. And I think doing research in that field, promoting novel ID framework, it's interesting, and that's why we're doing that, to trying to get away from just we need to be more circular. That would be my answer.
Thank you. Yeah.
Thank you. Now, before we move on with the opposition, let me also introduce you to the 2 online opponents that I forgot just a moment ago. We have Professor Baun and Professor Lahner, who are following this ceremony on screen. And the opposition will now be continued by Professor Baun, who is a professor of risk assessment of nanomaterials and head of the environmental fate and effects of chemical sections at the Technical University of Denmark, and he's a member of the assessment committee. Professor Baun, the floor is yours.
Thank you. Bonjour, Manon. I hope you're good. I just want to say thank you, first of all, for allowing me to evaluate your thesis, and also almost to be present in Maastricht today. I hope it's allowed that I congratulate you on the thesis. I think you have covered, have done a very nice and comprehensive overview and analysis of the possible barriers for reaching the goal of plastic circularity in Europe. I also think that your way that you also show here in your presentation, where you go material, product, and system, but you do it in the other order, which is more logical, is a scientific, valid, and appropriate way to address the problem. And you have demonstrated with your thesis very good understanding of how complex this area is, and also illustrated how important it is that we do something and that we get appropriate analytical tools to figure out if we are actually reaching the political goal or the vision, as you just said. So since you know, and people could hear that I'm more like a chemistry risk man, my questions will circle, sorry for this bad joke, around the issues of chemicals, but you're probably not surprised by that. So I've enjoyed reading your paper 3, and of course also what you write about materials throughout the thesis, and here you focus on the quality of plastics as a result of chemical constituents when we do mechanical recycling. And you conclude in the thesis that the manufacturers should promote the use of recycled materials by assessing the quality losses and the targeted end market. So I agree, it's from a material point of view valid and so on, but of course it seems you say contaminants to the plastic is something that affects the material quality. So I'd like to ask you if there's other things related to the plastics than quality that could be like a turn-off related to circularity when it comes to the recycling.
Thank you.
Other things that would not. Yeah. Great.
Sorry. Thank you, highly esteemed opponent. I will rephrase your question because the sound is a bit hushed. So you asked me if there is any other contaminant or contamination that can lead to a low-value recycle quality market.
Now I'm asking if there are other things than the quality that could affect whether recycling would occur.
Yes, the cost, of course. I think if you can buy 1 kilo of plastic for €1 or €2, and then the cost of recycled material is €100 for 1 kilo, it will be a barrier. I think that will be the two one. I think trust also, because it has been a waste, so you need to prove that what you will use in your new product is as safe as the first one. And then I think the other one is
safe.
Motivation.
Safe, if I can. Yes. When you say safe, could you say what do you mean when it's as safe as the first one?
I think it's like the Lavoisier, like everything you will put in the plastic will react and transform, nothing will disappear. So the question is like, how will it be transformed from when it's a virgin to a recycled material? And then it will need more tests and more, you do mix of chemical in the plastic. It's not just your polymer, it's also all the additives. So it's a big question mark on what result at the end, and that's why we need this analysis and this analytical tool, as you were mentioning before. But yeah, safe for me is safe for the environment, but also for the health and for the people, if we consider that plastic is used in our daily life everywhere. So that would be my answer.
Great. Could you think of any chemical groups that could be this kind of turn-off, where we could say, well, maybe circularity is not the best option if we have certain types of chemicals as additives, for example?
Yes, I see two types of answer. It's like, yes, we have an issue at the end because it's not safe, or either we think it from the beginning and we make it possible that we do not introduce the chemicals or the additives that will create an issue to be safe. So I think when I say that, I think about the safe design principle. So yes, we will have an issue, except if we deal with it at the beginning. Either we wait and we create solution to remove the contamination and the unsafe chemicals, either we do it at the beginning when we create plastic and we try to not put them first, if I understand well the question.
Yes, but you do. But of course, we will always have to look at the function of the plastic. So if we don't want it to catch fire, or if we want to have different surface properties and so on, it may be unavoidable that we use additives. We can't just use the polymer alone. And that's what I was hinting at, saying, but there's something, sometimes perhaps we must break the circularity and say there's something we must bring out of circulation. Because as you just said, it maintains in circulation. That may not be a good idea.
Yeah, I do agree.
So I'll turn another question towards the regulation that you also talked about a little bit before, and you also recommend that policymakers should develop and enforce regulations to promote the use of recycled plastics, which I agree on. But do you have any suggestions on how this should be done? I will offer you a couple of solutions. So is this something that should be done like upstreams, that the regulators should upfront say something has to do with plastic, or is something that should be done downstream in the waste management practices? What would be most efficient and how to do this?
I think in the linear economy, there is no end and no beginning. So you can decide to apply regulation on everyone because everyone should share the responsibility of creating circularity. So it should be upstream by first reducing the plastic production when it's unnecessary. And then you will go to the use also because everyone needs to contribute. And then you can go to the waste management. But it will not be fair to push on one stakeholder more than another one. In terms of regulation, it will be necessary to teach also and to do education, because even if you put the strongest regulation, it will not come with the optimal effect if you don't think that, if you put too much effort. It needs to be a concerted effort, as I illustrated in the paper one. I think for me that was one of the conclusions. Even if you put the strongest regulation, it will not follow if you don't have the technology. But if you don't have the people aware of what to do, it will not follow. It will not follow. So my solution will be to put a bit everywhere and to measure the impact before to implement the policy, such as dynamic material flow analysis, for example.
The final question, you also mentioned also now different stakeholder groups like manufacturers, waste management entities, policymakers, consumers that you outlined in your chapter 6 as well. Do you see any of these groups being more influential than others in overcoming the barriers that you have been addressing?
I will try to rephrase.
I know they all have to work together, but yeah.
Are there new stakeholders that should come in the circularity? And
no, not new. Any of these that you mentioned.
I think
where does the power lie?
I think we already see a bit of change. Before in the linear, we were having the one that produced and the one was extracting the resource. But then in the circular economy, we also see that people that were using plastic that are also interested to recycle it. So I think this vision that we have today about the circular or the plastic circularity will drastically change in the coming year because they have to adapt. They have to adapt with the quantity that is available, with the regulation that will implement it, but also the new way of consuming. And I hope it will be the case that it will need to be rearranged between them and to find more consumption to help to, I have this feedstock, what do I do with it? And not only just I recycle and then I don't know what I do with this recycled material. So for me, it needs to still be recycled, but a bit different, with maybe more link between each of the stakeholders in this cycle.
Thank you.
Okay, thank you very much. Then the opposition will be continued by Professor Lanner, who is also online, and who is a professor of waste and resource management and head of the Research Center for Resource Management and Solid Waste Engineering at the University of Kassel. And Professor Lanner is also a member of the Assessment Committee. Professor Lanner, the floor is yours.
Thank you. Thank you, Rector. Dear candidate, dear auditorium, dear committee. Yeah, I'm happy to be part of this committee, and first of all, please allow me to express my appreciation for the thesis. So it was a nice reading, and I think your thesis very nicely reflects the complexity of making plastic use with all its stakeholders and throughout the whole value chain more sustainable. And also it highlights that we need a better understanding of that by implementing analytical tools and then identifying effective measures. I think we had already quite some discussion already about that, what would be effective, what might not be so effective. And yeah, I obviously have some questions, and I would like to start with one related to, let's say, quantities of production and quantities of waste, because we are not yet in a, and probably will not be for a long time, in a like steady state system. And I would like you to reflect on something you wrote in your thesis. You say that the three largest plastic markets, or the, let's say, production shares, are packaging, building and construction, automotive. Now let's take the construction sector, and when we look at production or consumption, it has a share of, let's say, 20 to 30%, or no less. It has, let's say, around 20%. And when we look at the waste stream, we see that waste from construction and demolition, so from the construction sector, are around 10% in terms of share. So only half. Can you give me an explanation for that? So what is the reason for this sector having a larger share in the consumption than it has in the waste generation?
Highly esteemed opponent, thank you for your question. First, I think you referred to paper 4 that only focus on polyethylene, polypropylene, and polyethylene terephthalate as a polymer for the study. And also because...
So, just to interrupt you, that was... sorry, I heard myself. So that was just part from your introduction. So it's not yet referring to a specific paper. It's just an observation which you cite and which you will find in many places. And I would like you to refer to the mechanism, or to give me an explanation for why this is the case.
Change my answer, and then I will go directly to the lifetime function. It's because, on the contrary of packaging, the building and construction, they will remain in circularity or in use for longer time, between 20 and 50 years. So they're not available as a waste at the end of the year. And it will follow the triangular distribution, or it will be when it will be available as a waste. So the quantity you produce at the same year, it's not the quantity of waste that you have. That will be my answer for this.
Yes. So what would you expect then with regard to the share of waste, plastic waste from building and construction in the future compared to packaging? Would you expect an increase there or a decrease, or will it stay the same?
I think packaging will still remain the main sectors of producing waste, with a strong increase. For the building and construction sector, it might increase according to the renovation and the renovation rate and the waste that we produce. It might change. Instead of 50 years, maybe it will be only 30 years. And then it will increase the growth rate more it will increase the growth rate, but I don't think it will overpass, it will go higher than the packaging if we do not implement drastic change.
Yes, I would agree. So you have a lag phase, right? And you could look at historic consumption in order to say something about your future expectations. And based on that, you would expect an increase in the share, but not surpassing packaging shares unless you would drastically change the packaging system. So I agree. Another more general question, but now related to your to paper 2, where you talk about substitution frameworks, and as you said also in your presentation, we need substitution factors one way or the other in life cycle assessments. And my question, first of all, would be, why is that the case? So which approach do you use in order to deal with co-production in a life cycle assessment when you need to apply a substitution factor?
I do know I don't do life cycle analysis in my thesis, and in my scope it's a bit out. It would be interesting to share it, but because there is this, so as I understand it, is like you have the production of a recycled material that will have an impact, and then you share the benefit of not using the virgin resource among the product where we will use this recycled material. So if you use this market share or this suitability, the substitution is proper to one of your product, and you can then estimate what will be the rest of the ratio for the other product, and then having this co-production. I'm not sure it's exactly the answer you're expecting, but for me, it will be at least a better assumption of calculating for at least one of the co-products you will produce, rather than using the qualitative number they still use in the life cycle assessment for plastic products.
Yeah, that's what I'm pointing at, so that you need this kind of avoided burden in order to, and for this you need a factor to relate it to the produced recycled material. Yeah, that has also a name, but it's not so important. Let's look at the current practice of LCAs, even if you didn't do your LCA now, but the framework you're basing on is tailored actually for use in LCA. So the Warnburg et al. So let's say we have an LCA where they used a market price ratio between virgin and recycled material, recycled plastics, and they give a substitution factor of, I'm making up numbers here, but let's say of 0.6 to the recycled, because that's the share between the ratio between the market price for the recycled and the market price for the virgin. Why would you say this is not okay?
First, because market assumption is really uncertain. It's not sure. It changed. Also because without naming a product, I'm not sure which market, and I mean, it will be discussable, but it will remain a big uncertainty. Rather than if you use what happened before at the waste management system, and in terms of quality, you can be sure that you can use. From the publication I read about LCA, there is also for me an issue of why are you recycling and in which type of product you want to use it. And sometimes you say that you want to use it for the same type of application in closed loop, but did you check that you can really do it? Then it will be a proof also that you check this by using this full scope framework about substitution. And then it will give you a more real number, because maybe it's not 0.6, maybe it's 0.2, maybe it's more, not only based on the market. And then you will have a better and certain result at the end of your life cycle assessment.
Okay. Could it be larger than 1?
Can I ask you to repeat the question, please?
Yes, could it be larger than 1? So from just the way you argue, could it be that you have a substitution factor larger than 1?
I don't think so, because you will never have a collection higher than the quantity of products you of plastic waste you have, so the factor could never be higher than 1.
Yeah, I agree with the physical ones, but when it comes to quality or functional equivalence, I think it's not meaningful to have a factor larger than 1, but could you imagine a situation where you have a better functional properties or a better market response to a recycled plastics than to a virgin one? Let's stick to market response.
Then it will be clearly a limitation of using this framework to this type of calculation. And of course, it will change the result of your life cycle assessment in allocating more benefit for your recycling system. That is not what we aim for. We want a real calculation method. But if there is uncertainty and then the delta can be calculated based on the error that you make when you calculate, or like having uncertainty, I think it will not be an issue at the end. But that will be a limitation for sure.
Okay. I mean, at the end, it's anyway dependent on how you assess this market response and the quality, and if you don't allow for a larger than 1. But when you look at market response, for example, you might, with recycled PET, you could see a larger demand than for virgin in some cases because of commitments of producers for bottles, for example, which could lead to a larger than 1 factor. But never mind. I think my time is over. So
I think.
So thanks a lot.
Okay. So we move on to the next question, if you don't mind, but you can talk later if you want. So the opposition will be continued by Dr. Vervoort, who's a research scientist and technical leader in packaging and specialty plastics characterization at the Dow Chemical Company in Terneuzen.
All right, thank you for your presentation and also for the manuscript. I, like my colleagues, enjoyed reading it a lot. I learned a number of new things too in fields adjacent to my own field, relevant for the industry that I work in, which is concerned by the topic, but also concerned about the whole situation and about contributing positively to it, but also as a citizen, right? I enjoyed reading this as well. So I could read through the text as well that you have a strong personal motivation for the subject, and I appreciated a lot of collaborations that I could see as well with people from your colleague ECRs in cross-disciplinary work. So thank you for that. My first question is related to a very actual thing. So last week it was on the radio, and since yesterday, it's mandatory to have bottle caps attached to the bottle, right? It's a European directive that has become official now. So if you now think, okay, now it is official and it has been implemented, but if you think back like a few months ago or even a few years ago, and relate this to the framework that you set up for the analysis or the assessment of circular economy initiatives, how would you go about evaluating this initiative on your bubble chart? Where would it end up and why?
Dear esteemed opponent, thank you for your question. It's actually one of the initiatives we included, if I remember well. I do not remember the number, but I will try to do by head or by memory. For the circular economy principles, I think it will score not the reduction of primary resource, not the reduction of waste, because at the end you will still create the same amount of plastic at the end of the year. Then in the regard to environmental impact, you will reduce pollution in the natural environment, so it will score positively. So I will say that on the X axis, it will score either in the beginning of the positive part. Regarding the requirement, I think it will score on one of the best score, because I don't see any against, except maybe for the manufacturer that need to change all the mold of the caps to produce it, and it's quite it come at a cost, so they can be, why should we do that? But now that there is a regulation, it will be pushed, and they don't have a choice, so it will move even more on the y-axis. And then in terms of bubble, it should be either a small or a medium, because there is nothing in this initiative that contribute to increase the potential circularity of the material, except that improving recycling or like pushing it to waste management to be recycled in the base case.
So, well, pushing the industry creates jobs for researchers, right, to make the living hinges possible. But yeah, so you mentioned it will contribute positively to reducing environmental waste. I was wondering about that because, to my understanding, part of the regulation was driven by finding caps on beaches, for example. But where did the bottles go?
I think we found also caps because bottles have a high value. The PET bottle, I expect, or even the polyolefin bottle, they have a high value, so they might be collected also. If we don't talk only by Europe or we talk by Europe by the regulation, but they might be collected if it's in the other part of the world. For Europe, it might sink actually, in the water, I guess, or maybe it will be in another part. I guess it's small, so it can move in the environment more easily than the bottle. I have no other opinion, like no other further guess where the bottle are, but I guess maybe someone catch them. No, but more seriously, it's an issue. It doesn't fix all the issue. It say that we have now a solution for the caps, but it do not engage the consumer to put the plastic product in the good trash. That's for sure.
All right, thank you. I have another shorter question. I appreciate the effort put into all the different frameworks at different levels and different practices for different stakeholders, but to your knowledge, are these being actively used by decision makers nowadays? Yes or no? And if not, what would be required to lift them up from academic literature to practice?
No. No, it's definitively it's really hard to make the connection between the academic and the industry. There is really a gap. We are working in such a narrow field, but I think the industry will need the research. They will need the science because they might not have the time that we spend investigating, creating new tools, new framework. No, I think the challenge will be how do we create a common vocabulary to exchange and to use it in the good way? Because we can also see the drawback of making science for industry, and then it's not anymore. How do you say it in English? It's not fair, the word that I'm looking for. You might work for the industry and not for the science anymore, and that's for me a bit of a challenge, I think.
I'm not sure I understand that reasoning.
The industry, they will need the science to use the tool, but there is also a be careful sign for me of not doing science for the industry.
You mean okay. Yeah, I get it. Tailored to the industrial.
To show good
to make
results.
it easier or something,
exactly.
No, and I was not hinting at that. I was more thinking of how do we get boardrooms to consider these metrics and to actually really take them into account when they're choosing how to evolve which options to implement.
Reporting, monitoring, I think there will be more transparency. If you have to report, for example, the impact of your initiative at the end of the year by using either the type of metric that I created or the framework that I created, but also by reporting that we know that we're producing this plastic, we know it will be recycled in this type of quality and we can produce. I think we really need transparency and force by regulation maybe the industry to use this type of framework and report them.
Thank you.
Thank you. The opposition will be continued by Dr. Harings, who is Associate Professor Macromolecular Physics and Technology at the Maastricht Institute for Bio-Based Material at this university. Dr. Harings, the floor is yours.
Thank you, Pro-Rector. Dear candidate, first of all, congratulations with the completion of your thesis. I enjoyed reading it, and I also enjoyed the diversity. But like you are half material scientist, I'm full material scientist. So I lost myself in your chapter 3, well, on part 3, where you also include your paper that you have published in a renowned journal, right? The Journal of Hazardous Materials. And when I start reading, I lost myself when I touched the link, because there was another present, let's say, 66 pages of supporting info, right? So it's an enormous analysis that you have done on the samples that were polluted on purpose with binders and inks. And then if we look at page 8, you discuss the crystallization and ultimate crystallinity of the recycled granules. And we know PE seems a very simple material to many people, but it's actually very sophisticated. So the crystallinity has huge impact on the performance. And then you mention at a certain moment, you explain the increased crystallinity by enhanced chain mobility and chain relaxation, which is supported by your MFR measurements. But then later on, or actually a few lines ahead, you state that the inks and binders may function as anti-nucleating agents due to restricted chain mobility. So what's happening? It seems to be two opposing statements to me, and maybe it helps if you discriminate the processes of nucleation and growth in crystallization. Can you comment?
Yes. Dear esteemed opponent, thank you for your question. Regarding the first part on the 60 page, I think it's because I starting from scratch, there were not enough information about inks and how they are formulated, and it was only the research was only investigating separately the polyurethane or the nitrocellulose, but not even in the good application, or the pigment, but never together. So I had to.
But I appreciate that.
Okay.
So
I had to. Do the literature review. Then for the last part of the question, I think there were a difference, if I remember correctly, between the sample that I've been only with the binder and the one that I've been provided with the binder and the pigment that I called inks. In the case of the inks, there were pigment that was disturbing the nucleation by the presence of the remaining molecules, not what I want to say, the presence of the pigment structure by it. And then in the binder, they were also using, so for example, for the nitrocellulose, a lot of additives or plasticizer in order to make the nitrocellulose soft, so it can accommodate the shock during the plastic packaging. So I think that was also creating some disturbance in the material flow analysis by making the chain more slippery.
Okay. Because I think if I read carefully, here we have these two processes, and I think you're right that the binders and the inks together, they mobilize the system that would promote mobility, so that means the entropy changes in the system, and I think it should indeed, it can all be explained, I think, by increased mobility, and that is also reflected in your tensor graphs. So in the tensor graphs, you show that there is a difference in the first yield point and the stress needed to reach that yield point. Can you make the link between the additives, or? So what is happening at the first yield? Why do we see two yield points? Because we're so far above glass transition.
I think there were a lot of defects also in the other. We saw it in the 5 types of materials, so it cannot be only due to the inks and the pigment, because they were all having the same shape. So it was also coming from the main polymer, or like the LDPE that we used. But then, for example, if we think that the nitrocellulose is also degrading, I think there is also more shorter chain that was also decreasing the stress you need to apply to break the.
Manon Lisiecki, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense, and I request that you and your company await the results of our deliberations and our return to this room. Thank you.
Thank you, Director.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side. 7 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. On the line, I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile. Long road to the south side, 7 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Hit the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. And even though these nights seem long, I know that I am never on my own. Know you've won the battle once you've grown. To the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. What's on the line? I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile.
Manon Lisiecki. The degree committee here present has assessed the quality of your thesis and your defense. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Ragar is authorized to confer upon you this academic distinction in accordance with Dutch university custom. I invite your supervisor to now take the floor.
Please all rise.
There is a small formality connected. Manon, do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
I promise, yes.
Then by the authority vested in us by law, and in conformity with the decision of the committee here present, I hereby confer upon you, Manon Janine Chantal Lisiecki, the degree of doctor, and I grant you all rights attached by custom and law. As evidence of this, I will now present you with the degree certificate, signed by the rector, the prorector, the secretary, and the other members of the committee, and affixed with the official seal of the university. This is where you applaud. The entire thing. And then we turn that way and they take pictures. You just keep holding on.
Please be seated.
It is also customary for one of the promoters to hold a small laudatio. Dear Manon, dear Dr. Lisiecki, j'espère que tu comprends qu'après ce que les Français ont fait aux Belges hier soir, il m'est très difficile de féliciter une Française. Nonetheless, you have done very well and you deserve your congratulations. As an early-stage researcher in the Sea Planet project, you were part of a very high-profile but also very demanding program. There were a lot of events, internships, seminars, exchanges, some teaching. And on top of that, you somehow had to find the time to also do a PhD. To make it even more difficult for yourself, you insisted on combining different levels of thinking, as you evidenced today, from the system to the detail of the macromolecules. And at every turn, you were confronted with experts in those little fields. Somehow you managed to do all this and to create very interesting results. Not so long ago, I was visited by a Canadian professor who told me that the reason he wanted to visit was that he had read your Circularity Initiatives paper and found it very insightful. There really is no better compliment. The Inks paper as well was absolutely fantastic. I am particularly proud of it, as this is the work you have done during your stay at our Circular Plastics group here in Maastricht. Over time to come, I think it will become a pivotal paper in the field. It was a very challenging topic, but you stuck to it, worked very hard, and handled every setback. And I think this goes for your entire PhD. If there's one word to summarize you, I think it is committed on all levels. If there is a second word, maybe it's chaotic. The combination of both may have been what has actually kept you sane throughout these past years. So what I am trying to say is, bien fait Manon, Professor Damgaard and myself are very proud of you.
Merci.
Dear Dr. Lisiecki, also on behalf of Maastricht University, I congratulate you with the doctorate degree that you have just acquired. And before this meeting ends, I would like to thank all members of the degree committee and especially those coming from far. Your participation is much appreciated. And I would like now to offer our online members the option to briefly congratulate you, because they won't be able to move to the reception with us. So let me give the word to Professor Baum.
Manon, a lot of congratulations here from Denmark. In brief, I will say you are like plastic. You're strong, you're flexible, and you're very persistent, and that has gotten you to where you are today. And as you also conclude, you're also like plastic in the way that you're not circular in your argumentations. And that's a good thing for a scientist. So congratulations. You really earned this.
Professor Lerner.
Yeah, dear Manon, also from my side, congratulations. It was a pleasure reading your thesis and also the discussion today. We could discuss a lot more, and I also look forward to that at the DTU defense then, because that will be a bit longer. And please enjoy having finished this one. It was a great job, and you can be proud of yourselves. Thank you.
Thank you. Now, before this meeting really ends, we're going to take some pictures with the candidate and with the full committee, including the online members. And after that, we will all move to the Refter, that's elsewhere in this building, where you can all congratulate the new doctor. Thank you all very much for attending this milestone event for Manon Lisiecki, and I now close this academic meeting. Thank you.
Dr. Manon, please come forward.
You want this with you?
Paranin, please bring the degree. Supervisors next to the young doctor.